In order to design a successful engine for any given application, certain guidelines are needed to be known in advance, such as vehicle weight, final gear ratio of the differential, tire diameter and width, transmission type, automatic or manual, and the gear ratios in the transmission, and the intended use of the vehicle. Once these have been decided on, the cubic inch, bore and stroke combination, induction, exhaust, and camshaft can be selected. All of these things need to be decided on before the camshaft is selected. Throughout my years, I have witnessed many individuals who made an uneducated camshaft selection. This resulted in extremely poor performance and great disappointment. If these people had contacted a camshaft manufacturer and described to them their vehicle and its intended use, as we described before, such as the vehicle weight, gear ratio, transmission, etc., the camshaft manufacturer could have made them a quality choice. To help you communicate better with the camshaft manufacturer, we will now give you a short course on Camshaft Dynamics. The basic parameters of camshaft design are the lift, duration, overlap, lobe center, and lobe center line. We will explain these as we go through our example of a camshaft lobe. The camshaft lobe consists of the base circle, the heel, clearance ramps, the lift area of the cam, which is known as a flank, the nose or toe, which is the highest point of lift, and your lobe center line. The lobe center line is the actual line which will pass from the center of the base circle through the highest point of lift in the nose or toe of the camshaft, and that is what we will wind up using to degree the cam to the crankshaft. Total lift is dimension from the top of the base circle to the peak of the nose, as measured in thousandths of an inch. Duration is the total amount of time that the valve is actually opened off the seat through full lift and back to the point where it is closed and down on the seat, measured in crankshaft degrees. Overlap is a period of time that both the intake and an exhaust valve will be off the seat simultaneously. Lobe center is the measure of degrees between the center line of the intake lobe and an exhaust lobe. We will discuss them further in a few minutes. Before we do, I'd like to re-clarify one of our terms. We originally used the term lobe center and lobe center line. It's very easy to confuse these two terms. However, this is the terminology most commonly used in all publications. To clarify things for you better, we're going to change lobe center to lobe separation. This will make it much easier for you to follow what we're going to teach you now. For visual clarification, we're using a specially modified piece of camshaft with a modified lobe on it that allows us to pivot it in relationship with the rest of the camshaft. As mentioned earlier, and it's very easy to see here, here's your base circle. You have your heel at the bottom, clearance ramp, flank, nose, and this line represents the center line of this particular lobe. We're going to assume that this is the intake lobe for the rest of our discussion. Behind it is the exhaust lobe for the same cylinder. It also has the painted on center line for designation. The distance between the center line of the intake lobe and the center line of the exhaust lobe of the same cylinder is what is commonly referred to as lobe center, or as we have discussed, we're going to call it separation angle, because there is a separation of distance between the center lines of the two lobes. By using separation instead of lobe center, we can easily differentiate it between lobe center line. The closer together the tube-low center lines are, the more overlap will be built into the camshaft. If we were to increase the separation angle, and we're going to exaggerate it to make it clear, now we have a very large angle, very large distance between the intake and exhaust center lines. At this time, it's very easy to see that the exhaust valve would already be closed just before the intake valve starts to open. This camshaft would have little to no overlap designed into it, and which would designate it for very low RPM use. In general, camshafts with high lift will give you increased breathing potential for greater power output. Camshafts with either long duration or high overlap are designated for top-end power at the sacrifice of low-end power. Short centerline camshafts, approximately 104 to 108 degrees of centerline, will give you mid to high RPM use. Wide centerline camshafts, which average between 110 and 114 degrees, are designated for low to mid RPM use. When you degree a camshaft, you're actually aligning the position of the center line of the intake lobe with the crankshaft. If you find that you've had to advance or retard your camshaft more than 4 degrees from the manufacturer's recommended center line for proper performance, you should be looking to select a new camshaft. When you advance the camshaft in relation to the manufacturer's recommended center line, you will decrease the clearance between the top of the piston and your intake valve. Consequently, if you retard the camshaft from manufacturer's recommended center line, you will reduce the piston and valve clearance of your exhaust valve. Keep these two things in mind when you advance and retard your cam. Make sure you have adequate clearance, or you'll be in trouble real fast.